These abandoned banana stems lie rotting in muddy fields, slowly breaking down under insects, moisture, and time, completely ignored by most people. Across vast plantations, thousands of harvested stems are discarded daily, forming mountains of organic waste under the warm golden sunlight. But everything changes the moment these discarded stems enter a clean, high-tech factory filled with advanced machines and precision automation. Under bright lights, hidden fibers inside the stems reveal a natural shine, delicate yet incredibly strong, like something unexpectedly valuable. This journey takes us from raw agricultural waste directly into a futuristic production line where transformation begins instantly and efficiently. Heavy trucks unload massive quantities of banana stems onto conveyor belts, feeding the industrial system that processes them continuously without interruption. Sharp mechanical blades slice through thick stems, cutting them into uniform sections while water sprays outward under intense pressure. Robotic grippers precisely lift and position each segment, ensuring consistent alignment for maximum efficiency during the extraction process. Inside the machine, powerful steel rollers rotate rapidly, crushing the plant material with force and separating fibers from soft pulp. In slow motion, the stems collapse under pressure, releasing liquid and fibers in a dramatic burst of energy and motion. Green sap flows downward into collection systems, where it is filtered and later reused as natural fertilizer in sustainable farming. From the machine, long strands of creamy white fibers begin to emerge continuously, marking the first stage of transformation. Multiple processing lines operate together across the factory floor, moving fibers forward in a synchronized and highly efficient system. Mechanical arms collect and organize raw fiber bundles, placing them neatly onto racks for the next stage of processing. These fibers are then transported into washing systems, where deep cleaning begins under controlled industrial conditions. Inside ultrasonic tanks, microscopic bubbles surround the fibers, gently removing dirt and impurities without damaging their delicate structure. A fine mist of biological enzymes is applied, breaking down unwanted residue at a molecular level with precision and care. Water droplets cling to fiber surfaces, reflecting light beautifully as the cleaning process enhances clarity and texture. Large centrifuge machines spin at extreme speeds, forcing out excess water and further purifying the material efficiently. Steam-filled systems maintain temperature and pressure, ensuring consistent washing results across every batch of processed fiber. Fibers pass through infrared drying chambers, where controlled heat removes moisture and prepares them for high-quality refinement. Digital sensors constantly monitor humidity levels, maintaining precise conditions between 8 and 12% for optimal performance. AI-powered cameras scan every strand, detecting imperfections and ensuring only the highest quality fibers continue through the system. Now clean and refined, the fibers appear soft, airy, and golden white under carefully controlled lighting conditions. Advanced sorting systems separate fibers based on length and strength, ensuring consistent quality across all production outputs. In the control room, engineers monitor real-time data, analyzing performance through digital graphs and thermal imaging displays. Inside carding machines, thousands of fine needles comb through fibers, aligning them into smooth and uniform directions. In slow motion, fibers align perfectly, flowing together like golden silk in a visually satisfying and highly refined formation. The aligned fibers form continuous slivers, coiling into large containers as they prepare for the next stage of transformation. During roving, the fibers are gently twisted into thinner strands, increasing their strength while maintaining flexibility and softness. Spinning machines rotate at high speeds, turning the strands into durable yarn through precise mechanical control. Threads are wound onto cones in rhythmic motion, creating an organized and highly satisfying visual production pattern. Dozens of yarn cones spin together in perfect synchronization, demonstrating the efficiency and precision of modern textile manufacturing. A gloved hand gently touches the finished yarn, highlighting its softness, smooth texture, and impressive structural strength. High-speed looms weave the yarn into fabric, interlocking threads rapidly to form strong and flexible textile surfaces. Close-up views reveal the natural texture of banana fiber fabric, showcasing its unique patterns and organic beauty. Finished products appear, including handbags, clothing, and decorative items, all made from what was once discarded plant material. Workers carefully fold and package large rolls of fabric, preparing them for shipment to global markets. Banana fibers are also used to create paper, composite materials, and eco-friendly packaging solutions for sustainable production systems. At shipping docks, containers are loaded efficiently, ready to deliver these innovative materials to customers around the world. A split view shows farmers growing bananas and fashion models wearing the final products, connecting agriculture with global design. Aerial views reveal plantations surrounding modern factories, illustrating the full cycle from raw resource to advanced material production. The final product reflects innovation, turning simple agricultural waste into premium material through advanced technology and engineering. Banana fiber stands as a powerful example of sustainable industry, proving that waste can become the future of modern materials.